Mr. Balaji. He worked in Singapore and Australia as a technical consultant for about 2 years. In India, he worked as an assistant professor in the Department of Aeronautical Engineering for Hindustan University about 4 years and as an instructional designer for 3 years in India. He has completed dual masters in India and Singapore. In Singapore, he has done his Master of Science in Precision Engineering with specialization Additive Manufacturing and also Master of Engineering in Aeronautical Engineering. He has published 8 Indian patents in mechanical, aerospace and manufacturing.
Welcome to UGC lecture series on additive manufacturing. Today our discussion is about FDM, that is fuse deposition modeling. The topics which we are going to discuss today is fuse deposition modeling and the process parameters related to fuse deposition modeling, that is material loading, phase change, extrusion, solidification, position control, bonding and support generation. Our main focus is on process. How the FDM is going to work. What is the process involved in it? Say, as all AM process starts with normal CAD diagram or any re-engineered diagram. From that we are going to convert into STL file and then it is going to be the input for the equipment. So that is a general process. Similarly, that is going to work here. But what is the difference between other AM and this one? This is, we call it as extrusion based modeling or extrusion based system. So this is how the system is going to work based on the basic principle of extrusion, but there is a difference between normal extrusion process and this one. Normal extrusion process mostly it involved with help of mechanicals or screw type, or we call it as mechanical extrusion, but here mostly the application is going to work with help of addition of heat, or we can call it as thermal variation in the system going to extrude the material. Got it? So this is a basic principle going to involved in fuse deposition modeling. So how the system is going to work? Basically the input is given from the main system through the STL format. It's going to give the input to the main heated extruder head, right? So I will call it as generally the extrusion system. This is the major area of concern for us. While whatever may be the extrusion based system, this extrusion system is going to take the major part or major role in it. Okay, so first the input is given in the form of a filament, right, and which is going to undergo a phase change, that is from solid state to liquid state, and then it is going to extrude and then it is going to get solidification, then we are going to get the final product. So once the input is given for the extrusion head, it is going to start laying it up. Okay, again it's a process of layer by layer. Once the input is given, it's this extrusion head can have the capability to move till the working area, that is particular limit in x direction and particular limit in the y direction, and z axis is going to control with help of base or a build platform, right, which is going to move step by step based on the layer thickness. You can see the build platform which is going to move in the negative z direction and the part is going to build in the positive z direction. Okay, so this is how the system going to work for FDM. So this is a basic principle. Even we can achieve the layer thickness of 0.013 to maximum 0.005 inches of layer thickness, and the resolution in xy direction or in xy plane we can get up to 0.01. okay, and preferably the materials which nowadays they are mostly using ABS, polyamide, polycarbonate, polyethylene, polypropylene and some kind of waxes. So these are all the materials they have tried, and what is the advantage of compared to other commercial AM is this is, we can call it as comparatively the cheaper one, but some problem is there that we are going to discuss in detail. But how the system is working now, this is considered like a home based printer. Mostly you can develop in your home based on your own need. You can do modifications or based on your particular, say for example I need to have a different architectural view for my own projects, I can develop my own system. Likewise the system is more flexible to use in the home, like a normal 2D printers what we have in our home, right? So likewise we can use this one as well. So even we can remodify, restructure. Mostly they did with so many modifications with this fuse deposition modeling process. Here even the layer thickness we can modify as per our need, but in layer optimization we are going to see how we can achieve the better quality product. System is going to give you a particular thermal input to the system. For the, say for example, there is a input wire, input filament which is going to melt in this region, okay, with help of thermal input given by the system. Mostly here input they are using coils, thermal coils wound wrapped around the entire extruder head. That is how the system is working at the moment. But they have planned to change this one because they have a number of ways even you can give the input, right? That is in terms of thermal inputs we can give, but preferably at the moment this is effective, but they don't know, they want to improve this process by improvising this extrusion head. This is a major component. Even if you want to do any modification want to do, this is going to the major input system for the entire fused deposition modeling. Whatever may be the extrusion base, this extruder is always play a vital role, right? Because compared to other material based and other systems, this extruder base, this extrusion system is going to play a vital role. Say for example, if I have two extruder head, what is the advantage or why we need two extruder head? Mostly our material can build with the help of supports. Without support, most of our material we cannot build because we have a number of profile changes in it. Say for example, there may be a curvature, there may be a internal hollow structure, or there may be some external variation in a plane or whatever it may be. So for that we need a support material. So for that mostly we have to differentiate, that is the easiest way. So we preferably to have built material separately and supporting material separately. So based on that you can see the visual difference itself clearly. One is dark blue and another one is a light blue. The dark one is the original part and the light one is a supporting structure that can be removed once the process is completed. Here you can see some of the major features as I mentioned. Compared to other AM system, this is one of the competitive with other systems because it is easy and flexible to manufacture. That is a major reason, and it is the product we can make it strong and durable model, and we can go for a number of color choices, and this is waterproof and paintable. The maximum size they have achieved at the moment is 10 inches cross 10 inches cross 16 inches. So these are all basic inputs for FDM system. So the process parameters, what are all the process parameters which really going to contribute more on FDM? Whatever may be the system, because we are rely on system, that is a computer input. So mostly I don't want to concentrate more on that because that process is optimizing common for all AM systems, but this is very specific for fused deposition modeling or extruder based system. So what are all the major parameters which is involved, like how to load the material, that is also a role here. So that's why I mentioned even here material loading, phase change, that is liquefaction and extrusion, solidification, position control, bonding and support generation. These are all the major parameters which is related to fused deposition modeling. In detail we are going to discuss about each and every parameter. The first parameter is material loading. Why here compared to other systems material loading we need to concentrate here is mostly we need to have a continuous input. Continuous input, if say for example if it is a based system which is not directly involved with the extrusion or the phase change system, we can have flexibility. Can you understand? Say for example here the filament input, the extruder system is going to work as a combined unit. In other systems, say for example like SLS or SLA, the liquid or a phase change system going to have a separate unit and the input is given through a separate unit, but here it's almost we can have a combined unit. Can you understand the basic difference? So why we need to concentrate even on material loading? That is why this system has got unique advantage, or even you can say the unique system we need to concentrate even starting from material loading itself. While optimizing we can discuss even in detail. Say for example even while loading the material it will have its own advantages and disadvantages if the input even changes with the normal, even a very minor variation in the input, that we will discuss in detail in optimization. So here the solid loading in the form of a continuous filament, that's the preferable way we are doing it at the moment, or you can go for even like a small granules or pallets or something like that. That is also there is an option, but prefer to have filament that's a continuous input process. and the chamber is mostly with the help of a gravity field. We don't have much control over it, but still it has control with the help of a input itself. Got it? And then the material can flow through the nozzle. That is a normal process like other system. We input may be there laser, but here the direct product itself or a direct material itself. Okay, so you can see some of the filaments, it looks like that. So even they can have combined color in a same filament. There is option for that. Or you can have multiple inputs, say for example as we given for 2, even for the same material, for the part itself they have multiple color inputs. Again, if you go for more and more optimization in the extruder or in the level, again the cost goes higher. That is a problem, but at least minimum we can go for 2 or 3 colors at the moment with the feasibility of have multiple color input from the filament itself. They will measure the input at the moment. Say for example I need to have a product of 100 centimeter size, but for the initial 5 centimeter or 10 centimeter I need some color, say for example blue. They will measure according to that input filament itself. They will connect together with the different colors and the input can be modified. You can have multiple color inputs, and as well as we can have different varieties of inputs, say for example like a pellets or a granules also we can change it. Next one is phase change. This is important role in whatever may be the extrusion based system, right? Say for example here the input is going to change from solid to liquid phase. Almost we can say more than a melting temperature, but if there is a variation in the temperature, again that gives a problem. So they need to maintain a constant temperature to the maximum level. So here we can have material should be always passed through the nozzle. So the phase change input is in solid, changing into liquid phase and then extruding it, then it is solidification process, then we can get the final product. So here solid filament has to melt and supposed to have a phase change from solid to liquid, and then the temperature should maintain, as I said, it should be a optimum level. If there is a huge variation in the temperature, there is a problem that we will discuss in detail in optimization, how the temperature going to play a vital role in phase change or extrusion process. So some of the examples what may happen if you give high level of temperature input, some of the polymer has the capability to degrade. There may be possibilities. We can even the material can lose its property, so that we can avoid. And some of the material we need additional cooling time. Even after extrusion the material may feel the hardness, so it will take more time to get cooler. So what may be the problem if we are allowing it more cooling time? Problem of wrapping, or there may be curling, or possibilities even internal there may be a porous formation. So whatever may be the changes, it should be within a optimum time limit. That is better way to optimize the process parameters. Next one is extrusion. So this process you can even see, this is the major extruder head. This is going to control your entire layer shape and size. Can you understand? So extrusion, once the output is extruded through the nozzle, this is the one going to control your shape and size of a entire part, right? Whatever may be the modifications or changes which we are doing, this extrusion phase is going to decide your desired shape. So input should be controlled, or input should be given to the extruded system directly. I have some specific nozzle flow, say for example hardly 1 centimeter per second, or you can lesser than the, say for example 0.5 centimeter per second. If there is an input like increasing in the temperature, or there is a pressure difference in the chamber, maybe between the chamber and the surrounding temperature, what may happen? Can you think about it? Solidification. Okay, if there is excess temperature in the system, there may be possibilities. Even before it passes through the nozzle, there may be possibilities of solidification process. There may be possibilities. Even as he said, degradation also there may be possibilities. But what are all, even there is a minor change, say for example the input temperature varies from 15 to 60 maybe over 40 degree, what may be the process change? Main thing is flow rate will disturb a lot. So flow rate disturbed in that sense, some cases there may be possibilities of flow blockage, the entire flow may be blocked, or there may be possibilities of buckling at the entry point, because the input we are giving it as a solid filament, right? There may be a possibility of excess temperature if we get the back pressure, or we can call it as a drag force, that will make a twist or bend into the entry solid filament itself. So that won't allow the pipe or easy flow through it. Okay, that also may be the another constraint here. So we need to have the supply and the exit should have proper uniformity, so that we can attain a proper output based on the product development. There shouldn't be any mismatch at the entry level as well as in the exit level. So that is how the extrusion going to take place. Here we can have a chamber wrapped around a heating coil that is going to melt the material. This rollers is going to make it, or we can have it as a desired shape of the particular output. Even you can say the shape maybe have circular or spherical, or you can have like little elliptical, or you can have square input. Even they are trying for square input as well. The input are maybe square or rectangular at the output face. That also you can change based on the rollers, or you can have multiple rollers based on that, so that we can have a change in the shape of the filament drawing itself. That's why this system is going to play a vital role in this area. And solidification, this almost you can easily I didn't understand, because this is a normal process, but here the one major change is once the material is extruded, it should remain in a constant shape and size. That is how the extrusion should work. But there may be a possibilities of effects due to cooling and drying. What may happen if there is excess cooling or excess drying? There may be a slight modifications in the shape, or there may be shrinkage in it. So that possibilities are there once the cooling and drying is not done optimizely. Say for example, cooling, I have started the process from bottom phase to top phase. Bottom phase get cooler because say for example the size is different. Bottom I have very small size, and on the top I have very bigger surface. So there may be different cooling rate. This may cause the product to shrink, or there may be possibilities of distort from the normal shape. So how do we control that? We can discuss even in optimization in detail. So this what is the possibility here? How we can have a base, how to have a constant base output? So one of the ways we can have a minimum chamber and surrounding temperature, that maintaining the chamber and surrounding temperature in a minimum level, that is one of the way we can have a optimum product developed. Okay, there is a much difference between a chamber and the surrounding temperature. This product developed may have 100%, we can say there may be a porous. So once you are designing some machines, say for example you are designing your own machines for your own need, in that case these are all the areas you should concentrate more. Nowadays they are trying for ceramic, even ceramic powders they are converting into a filament, kind of a thin layer of filament, not this much thicker what we have seen now. That is little harder to melt and get a proper output. So they are maintaining it as a thin filament, and layer thickness also very thin. So they have optimization process even based on ceramics here. So once you wanna play around, these are all one of the areas you can optimize or you can change. And the position control, again this is one of the major area, how to have a proper position control for different layers, right? Mostly how we are laying it up from X to Y or Y to X, right? Say this is how the system is going to work for you. But what may be the problem? Say for example, once starting from X to Y, there may be a small deceleration at the end. Again I am going to lay up Y to X in this way, the zigzag manner. But the problem is particularly at the end of the product, say end of the component, there may be a deceleration. So what will happen if there is a deceleration in the nozzle head? Obviously one major concern is there may be possibilities of more material deposition. What are all the other effects? Say for example, that material may affect the previous layer, right? Because that layer is going to bond on top of it, right? Say for example, at one particular point there is a excess pressure on the top, there may be process of shrinking in it, or there may be process of internal dent, or there may be small gap which may leads to porous. So how to optimize? There are ways how to optimize. Do you have any idea? Or say for example that zero velocity we consider, like a zero velocity at the end of the products, can be optimized through any other way. Say for example I need to reduce the flow only at the end of the product. What may be the problem? I need to change the entire input, right? So again it's directly involved in coding part. We need to change the entire input parameter. Even you can say the STL file format itself you need to change. At that particular point the input parameter has to be modified. Any easiest way? So for example you can have a additional input in the material, or you can say the product can be developed as a additional supporting material. Even there may be a lot of material wastage. Instead the better way what they are planning or what they are doing at the moment, first slowly they are drawing the outline. Can you understand why I am mentioning it as specifically slower? This we don't have, even we can say this layer has different tendency to distribute from a normal level to normal layering level to this layering level, because normal layer what we are going to do, we are going to develop in a XY direction, but this is maybe a square or there may be a irregular shapes. Say for example I may have any bends or dents, so I need to have a proper output that may not leads to have a proper bondage. So that's why we need to have a slower rate to develop a edges. Understand? So mostly say for example I want to make a mouse of this kind. First this outer layer should be drawn very slowly and built up to your required level, then they are going to fill the inside layers. That is a normal process that you can make it up. So likewise they are optimizing. This is one of the method, and they found there is a different in internal material laid and the external surface. There may be possibilities of small gap, right? So what they are doing, they are overlapping only one layer at the end. So again you see, only for a small problem we need to have a n number of optimizations. So filling up solid layer or laying up a solid layer, we need to have optimized output because based on the need. Say for example as he said, if the material cost is very less, I am going for a very less material cost. In that case I can go for extra laying a layer, that is not an issue. Even I can just consider as a 10 mm product size, maybe a 12 mm, the 2 mm like a supporting material. Even I can give the input as a supporting material itself, which is not really as good quality as normal product. So we can even have that kind of modifications. But say for example mostly these products are considered to be little costlier, because we can have costlier product with higher volume is a better way, whatever may be the additive manufacturing process. So in that sense we don't want to waste the material. So that is always, even SLA we have seen the material cost is very high compared to other AM processes. SLA cost, the material cost itself very higher. So likewise once we need to have a optimized input so that we can play around these parameters. So how we can do is, we can lay up a external edge very slowly and then fill a internal layer up. Okay, bondaging. Again this is like once the layer is laid up, the next layer is going to bond on top of it. So once the process is done, it should acquire a particular temperature, then only it can have an input of next layer. What will happen? Anyhow the energy is going to given through the normal supply or extruder head, but if there is less energy, or in terms of say for example you can directly convert in terms of temperature itself, this has minimum or optimum level of cooling to accept a next layer of material, or else this may give additional fracture or distortion to the material. So for example if the energy is less, this may not have the capability to hold the weight, or we can say it doesn't have the capability to have the proper support to the above layer, right? In that case what will happen? There may be material fracture, there may be leads to bend or dent inside this particular layer itself, or there is a more input layer for the input level. Say for example this is giving more energy to the top of it. What will happen? This material may melt, that is rupture, and this material may wipe off, or it may leads to a bigger porous at the top of it. So whatever may be the layer, whether it is laid or which is going to lay on top of it, it should have a optimum temperature input. That is why compared to other AM process, this FDM mostly we are playing around only with the extruder head, because this is the one going to control the entire product development almost, we can say. So whatever may be the changes or optimization if you would like to do, that preferably we need to do only on the extruder part. That is the one which is going to control the entire development of it. So here, as we said, if it is less energy input, there may be fracture, and more energy input, there may be rupture to the previous material. Anyhow, this is going to lead to poor product development. And the next one is support generation. This support generation is a major parameter. Even you can say most of the designers has to work or concentrate more specifically for AM product development. This support generation is one of the key for them. Say for example, you have n number of product has been designed, or you can have different shapes of products has been developed already. But the concern is, if I need to have developed through this particular AM process like FDM or whatever, the supporting structures is always play a key role to develop an entire product, right? So designer has to think in this perspective. He has to develop the supporting structures along with the major part diagram. Can you understand? So this support generation is one of the key area he has to work for the entire product development. Even the product may be smaller. Say for example, I have different curl structures or very huge orthogonal variation in the shapes or whatever it may be. The product has got a number of variation in the shape. In that time, the product may be smaller, but supporting structure may be much higher. So he needs to concentrate in that perspective while developing AM products. So how important it is, like it has to, even if there is one support structure is missing at a particular point, there may be deviation in a normal product development. So you can develop using two ways. One of the way is similar material support. I'll discuss what are the advantage, disadvantage of it. Another way is we can have a different supporting material, that is secondary material support or like primary material itself. What is the problem if you are going for secondary material support, right? We need to have two extruder heads. Again, the control has to be taken care at a extruder for the secondary material separately and the primary material separately. Again, the process is tedious. Again, there is a rise in the cost of product development. So how we can eliminate how this similar material will support this process is, we need to have a very precise design, because all the material going to looks like a same component. We need to identify where there is a supporting material. Again, if there is a small variation in the design, there may be possibilities of breaking, or there may be possibilities of distorting the normal product developed. Okay, so particularly they mention it as very difficult to remove the part from the supporting structure. That is a problem if you are using a similar material, and this may leads to fracture. Understand? So and again, say for example, if how can I control or how we can modify this processes, I can have, there is a different layer distance. Say for example, I have particularly for a supporting structure, I have little more layer distance, but what may be the problem? If I have different layer distance between a support structure and a main product, like extruder head may damage the support structure itself, because this have too much of gap, or you can have like the gap is considerably very small, but even though this may leads to fracture, or this may distort the component which is going to lay on the top. And how do we maintain this? How do we have the changes? What the thing which we can do, one way is chamber and the extruder temperature we can control. That is extruder temperature, if you alter, what will happen? Exactly, the flow rate can be modified. So based on that, again the problem is removing the part is little harder in both the cases, because there is different temperature, it has different cooling rate, it has different drying effects, and the part which is laid on the top has different drying effects. So this may even again leads to problem in separating the major components. So that's why they preferably they go to have a secondary material support, even it is costlier compared to the similar material supports. So what are all the ways they can do? They can do using some 3 methods. One, visually they can change the color, that is primary material as we seen on it might be in dark blue and the supporting structure might be in light blue color, whatever. And how they can do another way through mechanical input. As we discussed, the supporting structure may have weaker supports. Can you identify the difference, right? So we can say, for example, instead of having a solid thin input, they may have only like a column, small columns, or they may have different shapes like studs or whatever it may be, just to hold the this is going to hold the part, that's it. So based on that they can give weaker supports even, but comparatively they can easily have the input to hold the particular part that they need to concentrate. Instead I cannot say that is I can have very lenient structure to hold it, that we cannot say. There may be possibilities of structural failure or the component may degrade at that point. So they need to calculate that, according to that they can give the weaker supports to the product. Okay, the last way is they can go for a chemical way, that is they can have developed a material, supporting material. Once they are dip into a chemical that may corrode the entire supporting structure alone, we can get the final product. But mostly we are going to use the same kind of material like ABS or polyamide. This has common tendencies of degradation. That is one of the concern. Mostly we prefer to have visual change or mechanical change. This chemical is there is a method, but it's very harder compared to other 2 methods. Got it? So this is how they can have secondary support structures which is going to help it. But compared to the similar, that is same kind of material which you are going to use, this is little sophisticated. The system is going to work in a harder manner. Okay, because we need to have 2 extruder head. One extruder head should be idle at a particular point, another extruder head should work at a different level. But as we discussed in the earlier classes, like we can have a crossover mechanism that can be adapted using these kind of methods. You can think over like why can't we mix, like having different materials even. Say for example, you heard of composites very well, right? One of the company, I forgot the name of the company, they have developed a 2 layer, like 2 different extruders, but it's in a different material composition. But the advantage of that one is it can work with freedom of axis, that is axis independent. One may lay like this, another may lay like this. So they developed a composite material, generally which is much harder than the existing one, that is it has good mechanical strength, and as well as the application of this one is they can go for a number of applications which is not existing at the moment. Even we can say some composite material they have developed with carbon fiber, and they have tried with even some metal matrix composite. Like don't think like metal matrix in the sense you should have some huge structure or stands like that, very thinner layer, but internally they go for a 2 or 3 layers with metal layer. But it has some problems, still it is not 100% developed. But like what we can think over, one of the way you can think over with the help of a crisscrossing the mechanisms, that is possible here. Even as I suggest, if you are going to develop some system, this is the way you can optimize your own systems. Even some may not be required for you, but once you derived it, you can go for once you are derived and if you can get out of the normal constraints, there may be possibilities of new applications based on that. Got it? So preferably if you want to work, you can work with the modifications which is not existing at the moment. So try like that. In this session we have discussed about fuse deposition modeling process and process parameters associated with fuse deposition modeling.
How is metal FDM process is feasible? Actually, the metal melting points are very higher, but actually our FDM products now they use up to 400 watts. It's very less temperature to achieve. For metal printers, what they will do?
One of the way they can do is they can have metal in the form of a small pallets, very small pallets that may not require that much high temperature, or they have redesigned the chamber in such a way that because the input is very thinner, as I said, they can make the input very thinner, but it may take more time to develop a product that is there. But if in that condition we can reduce the temperature range in it. Even like a input like a small pellets, they may give like a small pellets that may not take much time. Anyhow, it is going to have a small change in it for a short duration of time. In that time, this may not require that much temperature. There may be possibilities they can do. Even they are trying for ceramics, even as I said, ceramic powder also is not easier to do, but they are trying, and they, even like a phase change there is maybe little different. Even you can use like a binders, they can make it as a thin strip. Say for example, I'm giving like a powder, even consider like a small granule powders, they may have a phase change at that middle, they can use it. Can I understand? That's what I always prefer to say, like think about crossing, the criss-crossing two different AM process to achieve some output.
How viscosity is controlled in metal FDM process?
The major concern here based on the viscosity, that is a viscous flow, only we can control at the extruder region. That is, it has to be melted and the flow, that's what I said, the material characteristics has to be studied. It has to melt and it has to be converted. Or as you said, we can have some other material inputs to melt it and to get a proper flow fluidity of, particularly the fluidity of the liquid, that we need to study and we need to rectify in the extruder itself. We cannot do like other mechanism outside of the material layer, we cannot do that. The only way is whatever changes we need to do based on the liquidity or fluidity, we need to do in the extruder. That even if you are introduce any binder or material into it, we can do only in the extruder region. That's the only way. Particularly the material characteristics has to be studied.
So to control the flow rate, pressure plays the major role. Is there any device used to build the pressure, like a compressor or
if you go for any mechanical inputs, a screw type, or you can use some plungers on the top, or you can go for some gaseous inputs that may give additional pressure to it. That is possible. But what is the problem in introducing any other additional input to the extruder chamber is it's already a complex area where we don't want to introduce any other component. Even they are you don't even believe that they are very hard to place the temperature sensor inside it. That's also a complex area because the area is very smaller, where they don't want to make it more complex, particularly in the extrusion region, because the temperature change in a minor level that may leads to a major effect, particularly on the flow rate output. So they need to have a system in such a way that they need to control the pressure or temperature within the chamber without any external support. That's why they didn't introduce, at that moment they didn't introduce any other additional input. Even the small component may have any, say for example there is a gap in it, or there may be a trap of any additional atmospheric contamination may get into it. So they don't want to introduce anything. At that moment they are planning to have normal temperature alone as a parameter to control the flow rate. They can, as you said, they can introduce any mechanical input or gaseous input. They can give like a air or any other gas they can include to give a additional pressure. That is possible.
what is the source for build the pressure?
Obviously in extrusion system for sure we need some pressure, or otherwise material won't come outside. That's what they you know very well, within the chamber.
What is the source for the pressure?
That's what I'm trying to say. Pressure is directly proportional to temperature within the closed atmosphere. Once they increase the pressure or once they increase the temperature, obviously it is converting into pressure. That is the easiest conversion they are doing it at the moment.
So what are the maximum axis movements that the nozzle can travel?
If the product is concentrating mostly on 2 axis level, so that is more than enough. Even if they can give 3 axis movement as well, but that is again a complex, increase the cost. They are doing only for 2 axis at the moment. They can lay for the, say for example, instead of 10 inches they may go up to 40 or 50 inches. As I said previously, if they are using drones, small ornithopters or small copters, quadcopters, they can go for a number of flexibilities. Even they can lay for the entire room. That is possible. But we have a constraint in that how can we load the material. But the quadcopters, as far as my knowledge concerned, the quadcopters can be even built bigger. That is possible. Even you can have the quadcopters of size of 50 inches or 60 inches. There you can load the material on the top of it. They can extrude. That is possible. In that case, you can go for 3 axis. They can tilt to the any axis, or you can go for a Z direction. Any movement can be possible in quadcopter concern. You can.